So this is 12.2, day 2. And notice where the title says surface area of cylinders. Now, why do you think this is involved with prisms?
Well, because they're kind of like a prism in the fact that they have bases. It's just that the lateral surface is curved as opposed to being a bunch of polygons.
So the cylinder, is it a polyhedron?
No.
No. Okay, so the thing is that it's thrown into the same section for a couple reasons, or main reason is that there's some similar features. The big main feature is the fact that it has 2 bases. Now, the bases are not going to be polygons, and actually nothing about a cylinder is a polygon.
Right.
All right? It's all kind of curved, like Ms. Hochgraby just said. So it's a solid with congruent circular bases. Now, notice plural, and I'm going to make a little note. There's 2 of them.
Right.
That lie still in parallel planes. Just like a polyhedron, or I shouldn't say polyhedron, a prism has 2 congruent bases, but they're polygons, and they're also parallel to each other.
Right.
Okay? Now, we have some vocabulary that goes along with cylinders, some similar vocabulary also, but not as much. Because there's not, you're kind of limited with a cylinder. So with a cylinder, you still have an altitude or height. All right? It's still the perpendicular distance between its bases. The exact definition with a prism.
Right.
Okay? Now, the radius of cylinder. Now, why would we have to talk about a radius?
Well, because now we're dealing with circles. Circle bases.
Since the bases are circles, you're going to have a radius. Now, the radius of a cylinder is basically the radius of base. And what's a base?
The base is one of those 2 circles that are congruent.
So if I draw
on parallel
that,
planes.
here, and again, guys, being 3-dimensional, the cylinder is 3-dimensional. I know this doesn't look exactly like a circle, but you have to have that kind of little tilt to it. You know, it's kind of distorted a little bit.
Right.
So here's your center. If I draw a segment to a point on the circular base, okay, this would be considered the radius. Now, most cylinders out there will have a height that's kind of unique, okay? The height usually can go from one center to another center. Usually you'll see a height kind of drawn in here most of the time. And when you do, what do you think we call that kind of cylinder?
I'm guessing that would be a right cylinder.
You're exactly right.
Kind of, we talked about right and oblique, and that would mean that if it's connecting the centers, that should be a right.
Yes.
Figure,
Now,
right cylinder.
not all cylinders are like that, but like you mentioned the last couple days ago, you mentioned about the like a can of soup or even like a can of soda, right? Those are all great examples of cylinders. Most of them are right cylinders.
Yeah.
Okay, so just something to kind of keep in mind. So here's some more vocabulary, starting with what we just mentioned.
So we do have a right cylinder is a cylinder such that the segment joining the bases, the centers of the bases, which is exactly what Mrs. Palermo just drew, is perpendicular to the bases.
Okay.
All right, so that's the example of right. Now, we could have oblique, and think about that slinky again. You could just tilt that slinky. You could see oblique. We're not going to be looking at oblique ones right now. So, not even something to worry about stressing out about. Now, the lateral area of a cylinder is going to be the lateral of its curved surface. So, again, like the soup can label, right? That idea of that curved surface. Now, I want you to think for a minute. Is that really like based off of curves? If I flatten it out, if I took that soup can label and I took it off, what happens with that lateral area?
You kind of have a visual of this, guys, and sometimes it's kind of hard. But if you kind of flatten that and look at that picture there, flatten it out, you're going to, if it's a right cylinder, that lateral surface is going to be a rectangle.
It is. Just like we found our lateral surface of a prism to be, of a right prism to be a rectangle as well. So just something to kind of keep in mind. We're going to talk about that more in just a little bit. But the lateral area of a right cylinder will be a rectangle. The surface area of a cylinder is going to be, again, the sum of all the lateral area and the areas of the 2 bases. So it's going to be all the pieces, the lateral, the curved surface, that area, as well as the area of the top and the bottom, those 2 bases as well.
Why don't you draw a net to kind of see that visual before we see the formula?
So we talked about all the lateral surface, making that rectangle if I folded it out. But then keep in mind we still have our 2 circular bases. So we're going to have a circle on the top and a circle on the bottom.
Okay. So if I was finding the surface area, I would want to find the area of both of the bases, and they're going to be the same, right? So you're going to have two of those base areas, all right? And then I'm going to find the area of your the lateral surface, and we said it's going to end up being a rectangle, okay? So, and to find the area of a rectangle, it's just like your length times width, base times height. Well, the height of it is going to be the height of that prism because it's that
Definitely.
perpendicular distance between. Now, that whole other kind of the base of the rectangle, I guess you can call it. If I wrap that around the base, that's going to be the distance around the base. So that's not the perimeter, it's the circumference.
Yeah. So I'm just going to write a big C for circumference times the
Height.
because that's going to really make up the area of the lateral area. I'm going to write that as lateral area. And you know what? That is really our formula. That's where this comes from. Now, there's really a couple ways you could think of this. First of all, we know the area of the two bases plus the lateral area. I think it's easier to think about it as the circumference times the height.
Okay.
Now, I'll also have kids that say, well, circumference, I forget which formula is which. So if you need to, another way you could write this formula, it's the area of the two bases, how do I find the area of
a circular
circle.
base circle, it'd be pi r squared plus, and the circumference of a circle is 2 pi r times the height.
Now, to me, I don't necessarily need this formula because I know how to find the area of a circle and I know how to find the circumference of a circle. But that may be something helpful for you. To me, I try to keep these formulas as easy as possible because I know we've got a lot of them.
Now, and the other
But
reason,
this is
and
another
going to the one right above it, the two base area plus circumference times height, I'm hoping you're noticing that's very similar to the surface area of a prism. Okay. And the reason why is, again, why are prisms and cylinders? That was why I asked that question first. Why are they put in the same section is because there's so many things they have similar, right? They have the two congruent bases that are parallel. And that's why your surface area formulas are pretty much the same. It's just instead of circumference, there's perimeter.
And perimeter and circumference are pretty much the same idea.
Exactly.
All right.
Now, guys, when you're doing these problems, okay, again, because in the end, and then when you take this test, you're going to have all the different solids. So when you read the directions, make sure you understand what are you finding. So it says find the surface area. Okay, I know I'm dealing with surface area because eventually we're going to be talking about volume of a right cylinder. Okay, now, if it wasn't a right cylinder, this formula we wouldn't be able to use. It has to be a right cylinder. Okay, so I often write down the formula. So surface area of a right cylinder is
the area of two bases plus the circumference times the height.
Okay, and again, going back real quick, you can use, really, I'm just going to make a note, these are the two that are probably the most used.
Yeah.
Okay, you can substitute into this one and get it simplified down, or you can substitute it in this one. And there's pros and cons to both of them, okay?
Definitely.
It just really matters. It doesn't really matter. It just depends. Do you want to find it separate and substitute in, or do you want to substitute it all in and then simplify, okay? All right, so if we're using this approach, all right, we're going to find the base area. Okay, now how do you find the base area?
Well, for a circle, we know it's pi r squared, and they give us the radius is 4. So pi times 4 squared, or 16 pi.
Okay, don't put pi 16 pi.
Yes.
I've seen some people doing that lately.
Yes.
All right, then so that's this piece. I need to find the circumference.
Circumference is going to be our 2 pi r.
And the radius you already said was 4.
So 8 pi.
Okay, so I got that piece. Now, do they give you the height?
They do. It looks like on this one they connect the centers. And we see it's perpendicular to the bottom. It's also going to end up being perpendicular
So
to the top.
this is the height.
Height is 8.
Now, guys, something just a little side note. Sometimes they'll draw in and say they'll label something right here. That's still considered the height because
it's right.
As long as it's right, because it's still kind of the distance between the two bases, and that's really what height is. Okay. So we know that piece as well. All right, so we're going to put this in. So surface area is equals 2 and the base area times 16 pi plus
the 8 pi times our 8.
So that's going to be surface area equals, let's simplify this down.
All right, so we've got a 32 pi plus a 64 pi. And we can actually combine them. We can make this exact, which as I'm looking at this problem, I also noticed that there's no units.
And it didn't say round.
It didn't say
So
round.
leaving it in terms of pi would probably be our best option.
It probably would be.
So we can combine these because they both are in terms of pi. So we just combine the 32 and 64 and you
Right.
get a 96 pi. So we're going to leave this. This is our exact answer. Okay, we're not going to even type it in our calculator because we don't have units and it doesn't say to round.
And if we did, we could easily type that.
Oh
in our
yeah,
calculator.
very easy.
Okay. Next one. Find the height. Ooh, this one's different. We're not finding surface area here. Find the height of a cylinder. So that's talking about distance between bases. That has a radius of 9.5 inches and a surface area of 925.2 square inches.
Okay.
So here's the deal. We need to find a different piece in our formula.
Okay. Because
Okay.
they give you the surface area.
They give us the surface area. Now let's just write down the surface area formula.
I think
so we know
that's
we're
an
good.
excellent idea.
So surface area is equal to
The
Which one do you
area
want to
2 times the area of the base plus the circumference times the height.
all right. Do they give us the area of the base?
No, but they give you the radius, which will help you find
Okay.
the area of the base.
Do they give us the circumference?
And that's the same as the area. You got to find it, but we can. Okay.
But they do give us the surface area. So
Okay.
let's start. We're going to write our 925.2 is equal to, now let's go ahead and let's find those pieces.
Okay.
The area of the base.
So pi times 9.5 squared
Okay. Which 9.5 squared is going to give us,
is 90.25 pi.
and I'm going to leave it like that for now, but we know we're going to need to
Talk about it later.
Yeah.
Okay.
Type that in and get decimal. So what about the circumference?
So you're going to do 2 times pi times 9.5. So you get a 19 pi.
Okay. So let's go back to our formula. We said 2 times the area of our base, which we said was a 90.25 pi, plus the circumference times the height.
Okay. Now I see we could go ahead and multiply 2 times the 90.25 pi. So let's do that. So let's just let's just simplify down a little bit.
Okay.
All right. So that's going to get us 180.5 pi.
Plus our 19 pi h. Now, we want to just solve this equation for the height. Pi is a known value. It's not something, it's just going to get, we can type it in our calculator.
We
can
know
get
it's
decimals
about
there.
3.14.
Right. So what would I do to get this h by itself? What are the pieces that I
Okay,
need to
so
do?
here's what I often will see. So I want you guys to keep in mind. What I'm looking at, I'm like, 180.5 pi, and then add that to 19 pi. Well, they're both in terms of pi. Can I do that?
We can't because before I could add, I would have to multiply.
Yes.
So we need to deconstruct this piece.
Okay, it's kind of like if you have an equation and it had like 30.
Imagine the pies weren't there for a
Yeah.
minute.
You wouldn't add those together. They're not
Right,
like terms.
exactly.
Okay, you can't combine because they're not like terms. One has an H, the other doesn't. So let's subtract the 180.5 pi on both sides.
Okay.
All right, and when I do that, okay, notice that's going to cancel out. Here's the deal. We can start typing this in our calculator, and that's what I would suggest. And we're going to leave it in our calculator as we go. Okay,
Yeah, leave it
so
with
I'm
the
going
decimals.
to put 925.2 because that's the surface area minus the 180.5 pi. And when I put that down, it's about 358.14. Do you want to do?
Let's just leave it.
Leave it. Okay.
Well, here's the thing.
You're gonna keep it
I don't
in your
care if
calculator.
you round it on your paper. Just don't touch
Exactly.
your calculator.
Exactly. That's what I tell students too.
Yeah.
All right. So it's gonna be 19 pi h. Now I'm gonna get rid of the 19 pi. So I'm gonna divide each side by 19 pi. Now we've talked about this before. If you're ever dividing by basically two things, you need to put it in parentheses. Okay,
Love it.
so I'm going to leave that in calculator. I'm going to go ahead and push divided by, and then parentheses 19 pi. That's one of the biggest mistakes. Push enter, and it's about 6.
Okay.
And that's to several decimal places.
Yeah.
So 6 inches.
And because height is just a linear unit, it makes sense that we should have just inches, not inches squared, because we're not finding surface area in this question.
Now, something like this one, you could check and put it back in for like your surface area formula and just see, does that 6 inches, when you put that in, does that actually get you the surface area of 925.2? So Ms. Hogravy's kind of writing down what she needs.
So you could
put
check
that in
it
and then see
and
if it
make
works.
sure that it gives you the 9.
This, I would say, this is probably one of the most missed questions, something like this, because we're forgetting of our algebraic rules.
Right. Or not using parentheses when we divide. That's another.
Yeah, uh-huh.
I don't know how many times we could say that and people will still make mistakes, Miss Palermo.
So be careful with that. All right. What are we dealing with here?
This is not a cylinder.
No, it's not. But it's a good refresher, okay?
Yes.
Because this whole section's dealing with cylinders and prisms. So we're finding the surface area of a right prism. So before we get to going with this, let's write down that formula. So surface area of a right prism is?
The area of 2 bases, so 2b, 2 big B, plus the perimeter times the height.
Again, it's a capital B, not a
Right.
lowercase b. Base areas, not, you notice she doesn't say 2 bases.
Right.
To area the bases, okay? Now, we need to understand that it is a right prism. Now, the fact that it's a right prism, what that means is what?
Well, all of the lateral faces are going to be rectangles.
Okay, and what else does it tell you?
They give us the height is the lateral edge.
So in this case, what would be the height?
The height is going to be the 8 because that's what's connecting the 2 bases. And I know that the bases are the pentagons because I know that they're not rectangles.
Exactly.
Easy enough to say
So the
that.
base is a pentagon, all right, and your height is your 8 right here, okay?
The only time that it's not going to matter what you use as your base is when
Mm-hmm.
you're talking about a rectangular prism because all of the faces are rectangles.
Exactly.
Any other shape, you need
It
to
does
really
matter.
look for what is the non-rectangle there.
Okay, so if you were redrawing, if you wanted to redraw at all, you could just redraw the pentagon. Now, I may not even draw the pentagon. Notice what kind of pentagon it is.
Oh, it's a regular pentagon.
And we know we spent so much time in chapter 11, which we're going to see a lot in chapter 12, to find the area of a regular polygon. So I'm going to make a little side note here. So to find the area of a regular polygon, how do you do that?
We did half apothem perimeter.
Okay, so here's the deal. I could redraw this, or I could draw one little piece. So we're going to talk about that little piece in just a minute. Now, going back real quick, notice the area of a regular polygon involves the apothem and the perimeter of the polygon. Notice this capital P. Are these the same thing?
They actually are because that is the base that I'm finding the perimeter of, and in the surface area formula, I want the area or the perimeter of the base.
Okay, so it might actually help to find the perimeter of the base before you find the base area in this case. Some of the problems we did yesterday, we did the base area, then we found the perimeter.
Right.
So in this case, I would do that. Now, so we know the height. Okay, so let's we're focusing on the pentagon. Again, if you want to redraw it, I'm just going to do that just so you can have kind of a visual and not focus on the whole entire prism. We know all the sides are the same. And do we know the side lengths?
We know that they're all 5.
Yeah, so that can help us find what right away?
Perimeter,
So perimeter of the base, so capital P, is taking side length times.
the number of sides, 5. So 25.
So I know this piece, which that means I also know that piece for the area, okay? So how are we going to find the area of the base?
I just really need the apothem.
Okay, so drawing in the apothem, that goes from the center, and it's always perpendicular to the base, right?
Yeah. Oh, yeah, I remember this little right triangle that we used before.
To make that right triangle, what else do I need to draw in?
I need to draw in a radius.
Now, do I need to know the actual radius of
I don't
this?
need the radius. I
no.
just need it to see the triangle.
Okay, so that's your apothem. Again, if you want to just draw, if you were just drawing something, not necessarily the whole pentagon, your apothem, your radius, and this is, let me go back real quick. Hold on. This right here is this 5?
No, that's not the whole side length. It's 2.5.
Remember,
it's half of this.
half
side.
of it. That's the little piece.
Right.
All right, now, how are we going to go about doing this? What do I got to go now?
Well, Okay, I remember like if it was a hexagon, it would have been a 30, 60, 90 little triangle. Pentagons were weird. We ended up having to use trig.
Okay.
So we need to find the central angle.
Okay, and the central angle, remember, again, is formed by 2 consecutive radii, and we only want half of that. So
Right.
how do you do the central angle?
So we take 360 and we divide it by our 5.
Which is the number of sides, and that gets you
That gives us 72.
2. And then I'm going to divide that in half and
We get 36. So that means that that angle up there is 36.
okay.
Oh, I'm going to have to use some trig here because I know that that's not a special right triangle. So I'm looking at that. Those two pieces are the opposite and the adjacent, so I'm thinking tangent. So the tangent of 36 is equal to our 2.5 over A.
All right.
All right. And we could really just say A is a 2.5 over tangent of 36 at this point too. If you want to cross multiply and you realize you get A times tangent of 36 equals the 2.5, but you're going to end up dividing by that tangent of 36. Should we go ahead and get that decimal value, you think, or should we leave it as exact as possible?
Let's go ahead and let's just go ahead and get the decimal value.
Okay, so we're going to take 2.5 and divide it by tangent of 36. And that is going to give us 3.44 approximately.
Okay, again, if you
I'm leaving it in my calculator.
if you have to, if you're not going to leave it in your calculator, you got to do 4 decimal places.
Yes, and then
okay?
we would want 3.4. Really, we're going to have to make it a 1 because then it's be 0.95.
Okay. All right, so that's the apothem. Now we're focusing on, what's our whole goal again?
The area of the base.
All right, so we're gonna keep in mind this is kind of our key. We're trying to still focus on this piece, and we're using this formula over here. So to find the base area, we're gonna take 1/2 the apothem, which is
That 3.44,
which we're leaving in our calculator, times the perimeter, which we already found was
25.
25.
So I'm going to leave the big long decimal, and I'm just going to say times 25 and either divide by 2 or times 0.5. And that is going to give me 43.01. Because
Okay.
I could get more specific. I'm going to leave that in my calculator too.
Okay. So again, don't touch the calculator. Leave it there. All right. So we're going to go, and we can do that because we're dealing with units here. So surface area equals 2 times that base area. And then we're adding on perimeter, which is 25 times the height, which is 8. Okay. So we're going to leave this in our calculator, right?
Right.
So,
So I'm just going to say
multiply that-
times 2,
so that is
86.02.
And then when I add 25 or 25 times 8, what's 25 times 8? Let's see.
Well, that should be 200, right?
Yeah.
'Cause
Yeah. So 200, and I'm just adding 200 to that, right?
Right. Which should give us 286.02 if I round to the hundredths place. And usually that's what we'll kind of ask of you, centimeters squared.
So again, throw in this idea of a prism in it. Still similar formula to a cylinder. And again, notice all the little pieces that we had to do. Kind of break it up.